In this video we're going to look at solving quadratic equations. And although there's many different ways to solve a quadratic equation, we're going to look at one of the most common, and that is to use the Null Factor Law. So the Null Factor Law states that if a times b is equal to 0, then a could equal 0, b could equal 0, or a and b could both equal 0. As you can see from the CAS calculator screen shown on the left, when we solve an equation such as 3x times x plus 6, either 3x could equal 0, in which case x equals 0, or x plus 6 could equal 0, in which case we would get x equals negative 6. The same holds true for the next one, which is already in factorized form, and we can see that if x plus 2 times x minus 5 is equal to 0, then x plus 2 could equal 0, giving x is equal to negative 2, or x take 5 could equal 0, which gives x equals 5. And the same thing holds true for all of those that you can see down there on the calculator screen. So to apply the Null Factor Law to solve a quadratic equation, the most important thing is that the equation must equal 0. We can't have an equation that equals some other number. It has to equal 0. After we've got it in that form, we may need to factorize. So we can remember that there's several different ways of factorizing depending on the expression that you've got. So you may need to factorize by removing a highest common factor. You could factorize using a DOPS pattern or a difference of perfect squares pattern if that's applicable. Or you might need to factorize by inspection, and we've already had a look at two different methods, by inspection easy and by inspection hard, which apply to quadratic trinomials. So for each of the following, we're going to solve the equations for x. So for part A, we have negative 5x times x plus 2 is equal to 0. So applying the Null Factor Law, we would say that minus 5x could equal 0, or the thing that it's multiplied could equal 0, so x plus 2 could equal 0. For the first equation, if we have minus 5x equals 0, we can divide both sides by negative 5 to get x by itself. So therefore we would find that x is equal to 0 divided by negative 5, but 0 divided by any number is simply 0. So one of the solutions is x equals 0. Looking at the second part of the Null Factor Law, we saw that x plus 2 could equal 0, and subtracting 2 from both sides of that equation would give x by itself. So that would give us x equals negative 2. So that is the second solution to this equation. Now at this point, I'd recommend that you pause the video and have a go at the second question on this slide by yourself before I do it for you. So if we do have a look at part B, we can see that the equation is both equal to 0 and factorized, which means, like part A, we can apply the Null Factor Law straight away. So the Null Factor Law would tell us that x plus 3 could equal 0, or the part that's multiplying that could equal 0, so x minus 10 could equal 0. To solve these two equations for x, for the first one we could subtract 3 from both sides, and that would give x is equal to negative 3 as one of the solutions. For the other part that came out of the Null Factor Law, we said that x minus 10 could equal 0, so if we add 10 to both sides, that would give us x is equal to positive 10 as the second solution to this equation. For part C, we have x squared take 16 is equal to 0. So we can see that the equation's equal to 0, but it's not yet factorized. So we need to think about what technique we could use to factorize this. And there's no common factor between the two, and it's not a trinomial. So one of the only remaining options is to see if it's a difference of perfect squares. So if we did try and express that as a difference of perfect squares, x squared take 16 could be written as x subtract 4 times x plus 4, and that would still equal 0. And you could check by expanding that x minus 4 times x plus 4 does equal x squared take 16. So now we can apply the Null Factor Law, which says x minus 4 could equal 0, or we could have x plus 4 is equal to 0. For the first equation, x take 4 equals 0, we would add 4 to both sides of that equation, and that would give x equals 4 as one of the solutions. For the second part of the Null Factor Law, which told us that x plus 4 could equal 0, we'd subtract 4 from both sides, giving x is equal to -4 as the second solution to that equation. For part D, we have 9x squared take 5 is equal to 0. So once again, the equation's equal to 0, and we just need to factorize the left-hand side in order to solve this using the null factor law. So once again, there is no highest common factor between those two terms, and it's not a trinomial, so we're not going to factorize it by inspection, which means it's quite possibly a difference of perfect squares again. So we could write this as 3x take, but instead of having an integer number that sits in this position, the square root of 5 is just that. So it's got to be 3x minus the square root of 5 times 3x plus the square root of 5, and that's still equal to 0. And using a grid, you could check by expanding that that left-hand side is still equal to the 9x squared minus 5 that we started with. So using the null factor law now, we could say that 3x take the square root of 5 is equal to 0, or we could have 3x plus the square root of 5 is equal to 0. Now if we solve these equations, we could add the square root of 5 to both sides of this equation, and that would give 3x is equal to positive square root 5, and then we could divide both sides by 3, and that would give x is equal to the square root of 5 over 3 as one of the solutions to this equation. For the second part of the null factor law, we'd start by subtracting the square root of 5 from both sides of the equation, and that would give 3x is equal to negative square root 5, and then once again dividing by 3 would give x by itself, and that would give x is equal to negative square root 5 over 3, and that would be the second solution to this equation. For part E, we have the quadratic equation x squared minus 10x equals negative 21, and we want to solve that equation still for x by using the null factor law. However, the first thing we need to do if we're going to use the null factor law is have the equation equal to 0. So we're going to start by adding 21 to both sides of this equation. So therefore we have x squared take 10x plus 21 is equal to 0. And now that's a quadratic trinomial that we can factorize by inspection easy, because the x squared term has a coefficient of 1. So when we factorize by inspection easy, we look for factors of the constant term, so factors of 21, that add to give the negative 10, or the number that's multiplying x. So if we consider the factors of 21, you could have 1 and 21, or you could have 3 and 7. However, we need these to add up to negative 10, so we could use negative 1 and negative 21, and negative 3 and negative 7. And now we check which pair adds up to being negative 10, and you can see the second set of numbers, negative 3 minus 7, does in fact equal negative 10. So we can use those two numbers to help us factorize this by inspection. So factorizing the left-hand side, we'd have x subtract 3 times x subtract 7 is still equal to 0. And the null factor law would tell us that x take 3 could equal 0, or that x take 7 could equal 0. And now if we add 3 to both sides of this equation, we will get our first solution, that x equals positive 3. And adding 7 to the second equation that we found using the null factor law will give x equals 7 as the second solution to this equation. Next, if we look at part F, this equation's equal to 0, so we just need to look at factorizing the left-hand side. And first up, we can see there's a common factor that we can take out first, and that common factor is 2. So this equation could be written as 2 times x squared plus 8x plus 16 is equal to 0. Once again, we can look at factorizing that part inside the brackets by inspection easy. So that means we're going to look for the factors of 16 that add up to 8. So the factors of 16 could be 1 and 16, 2 and 8, or 4 and 4. The next part of this process is to identify the pair of factors that add up to 8. So looking down that list, we can see 4 and 4 does add to give 8, So we can use those numbers to help factorize this by inspection. So therefore we can write this as 2 multiplied by x plus 4 times x plus 4 is equal to 0. Now we can apply the null factor law, and there's actually 3 things that are multiplied together. We have 2 times x plus 4 times x plus 4. So the null factor law would say that 2 could equal 0, or that x plus 4 could equal 0, or that x plus 4 could equal 0. But we don't need to write that out twice, because it gives us the same value in the end. It just means it's a repeated factor. So the idea that 2 equals 0 is absolute nonsense, so that's not going to be anything to do with our answer. So we just need to look at this x plus 4 could equal 0 statement. And to solve that, we'd subtract 4 from both sides of that equation, and that would give us our only solution that x is equal to negative 4 for this equation. And now before we move off this slide, I'd just like to discuss exactly what a solution is when we've found them for an equation. And that is that we should have found a number that when we substitute it into our original equation, it satisfies that equation. So we can check if our solution x equals negative 4 is a solution to 2x squared plus 16x plus 32 equals 0 by substituting it back in. So therefore, if we substitute it in, we'd have 2 times negative 4 squared plus 16 times negative 4, and then we would still have plus 32. And that would equal 2 times negative 4 squared is 2 times positive 16. And then we'd have 16 times negative 4, which is going to be negative 64 plus 32. However, 2 times 16 is simply 32. So we have 32 minus 64 plus 32. And that does in fact equal 0, which is what we wanted the equation to equal in the first place. So because that is true, it means that this solution is indeed correct for that equation. And we could check all of the solutions we'd found previously by substituting them back into the equations that we started with. So for part E, you could check that x is 3 is correct by substituting it into the equation and seeing if it gives us a correct statement at the end. The same could be done with x equals 7 for part E as well. So our last example for this video is the equation 2x squared plus 3x minus 5 is equal to 0. And this is a quadratic trinomial where the coefficient of x squared, the number multiplying x squared, is not 1. In this case it's 2, which means we need to factorize this by inspection hard. That process involves taking the coefficient of x squared and multiplying it by the constant term. So we're going to do 2 times negative 5, which means we're now going to look for the factors of negative 10 that add to give positive 3. So that's just the 2 times negative 5 gives the negative 10, and that the plus 3 that we're looking for is the coefficient of the x term. So factors of negative 10 are negative 1 and 10, 1 and negative 10, negative 2 and positive 5, or 2 and negative 5. So if we want the pair that adds to 3, we can look down that list and see that negative 2 plus 5 is equal to positive 3. So we can use these two numbers to help factorize by inspection hard. So the next step in our process is going to be to split up the middle term, which is plus 3x. So to do that, we're going to have 2x squared, and using the negative 2 and 5 we had before, we're going to have minus 2x plus 5x minus 5 equals 0. And now we're going to factorize by grouping, so we're going to group the first two together and the second two terms together. So in the blue, we can see that 2x is a highest common factor, so we can write this as 2x bracket x minus 1. And then in the green, 5 is a highest common factor, leaving behind x take 1, and that will still equal 0. And now we can see that x take 1 is a highest common factor between the blue and the green term. So therefore, we remove x take 1 as a highest common factor, and that will leave behind 2x from the blue because 2x was multiplying x take 1, and plus 5 from the green because it was 5 times x take 1 in the previous line. and that is still equal to 0, so all we've done is factorize the left hand side, and we've now got to apply the null factor law, which says that x take 1 could equal 0, or what it's multiplying could equal 0, and that is 2x plus 5 could equal 0. So if we solve x take 1 equals 0, we add 1 to both sides of that equation to get x by itself, and we find that x equals 1 is a solution to this equation. And if we consider the next part of null factor law, which said 2x plus 5 could equal 0, we're going to start by subtracting 5 from both sides of the equation, which will give us 2x is equal to negative 5, and then to get x by itself we can divide both sides of the equation by 2, and that gives us the solution x is equal to negative 5 divided by 2. So that is the second solution to this equation. And just as we did on the previous slide, you could check that they are the right answers by substituting them into the original equation, 2x squared plus 3x take 5 equals 0. So after this video you should be able to understand the null factor law, which states that if a times b equals 0, so if any two things multiplied together equals 0, then a could be equal to 0, b could equal 0, or a and b could both equal 0. You should be able to solve quadratic equations by factorizing and applying the null factor law. And you should understand that a solution is a value that satisfies an equation.